Hello. Okay, let's talk about barriers within Volumator. So the purpose of barriers is to constrain detection rays and the drones to specific areas that you choose. So let's say I want to capture this area here, but I obviously don't want detection rays or the drones to fly into this area here, and ditto for this bit here. I want this to be a separate volume. And so in order to do that, we'd create a barrier here, and that would block the rays and the drones from flying into these sections here. So I try to make it as easy as possible to build these barriers, and there are three types. There's volumes, planes, and fences, which I'll show you in a second. And it's very easy to use. It's sort of interactive in that you fly to where you want the barrier to be, and then you press build barrier, and there it is. It's built one there, and that's a volume. And then a plane is the same, except that it's just a two-dimensional sheet, and it will place it at the closest edge to where you were. And then the fence is very similar to vertices only mode, except it doesn't do a closed loop. So we're going to start barrier fence building, and it adds our first point. We're going to add our second point here, and let's finish it over here. And like I said, unlike vertices only mode, it doesn't do a closed loop. So when I add my final piece here, that will be the end of it. It won't link back to the beginning. And so you can see you've got 1 point, 2 point, 3 point here. And that's created two planes. It's basically chains of planes. Okay, let's get rid of them here though. So let me just again highlight how they work. So if I was to start piloting here, you can see the pink dots of the detected areas here. So that's obviously going to create a volume that's going to go into here. But with the barrier volume, we'll come into this section here. We'll build it. And then this time now we're going to go back to piloting. And now you can see that it is not detecting anything here, but it would have here. And that will allow us to constrain the volume to the section that we care about. And for this last bit here, we'll add a plane right on the edge like this. So now if I fire out a drone from say here, you can see the drone's not flying out there. It's not going past here. And the volume should be right to the edge here, just like that. Perfect. Okay, let's have a look at another example of why you would use a barrier fence. So in this example, we've got a little area. Maybe we want to capture this here. Maybe we want to use a depot to sort of own the volume that lives here. Or if you haven't got that far in your Volumator experience, maybe you just want to fire out a drone and build this. But unfortunately, of course, it's just going to fly out and not build a very good volume. So we need to constrain the drones to this area here so we can just really quickly add, say, a fence start point here and an end point here. And now let me just size it accordingly. And now if I was to use a drone here, you can see it's getting constrained by the fence, and there it is. So this is a way that you can constrain exterior areas or areas that don't have geometry to specific places that you want. And you can see that it didn't take me very long at all, and it works really well. And it also means, of course, that, like I briefly mentioned, that you can use depots in areas that otherwise you think you might not be able to, which means you can automate processes. Okay, let's look at some other examples here. So in this case, say we have a room here that we want a volume for. And then here we also have another area that we want a volume for. And then we have a tunnel connecting them that we also want a volume. So we have 3 volumes. And now obviously we're going to need to block this off with a barrier, and we're going to need to block this off with a barrier. So if we were to add a barrier here, let's say a barrier volume like this, and then another one here. Let me just line this up a little bit. Okay. This will work great from this perspective and from this perspective, because the volume on this side will come right to the edge. Let me just enable opacity. The problem is that the section in the tunnel here is going to be the wrong size. Let me show you. So if I just quickly build a drone, now you can see our volume comes to here rather than all the way to the edge. You can see it's hit the barrier volume. It's pretty obvious why that's the case, because it's a barrier volume and it has 3 dimensions, it has some depth to it. So instead we'll use a plane like this, come right to the edge here, and we'll get another one here. And because they're infinitely thin, so when we build our volume here, it should come right to the edge here, which it does. Yay. And so we can safely build volumes on both sides and the tunnel and know that it's going to be the right shape. And so that's the point of using planes rather than volumes, is when you need to have volumes right next to each other. Another good example of where you might want to use a barrier plane is with really skinny walls here like this, or maybe window frames, things like that, things that don't have too much depth to them. So if we come in and put our plane here, that way we can ensure that the volume doesn't sort of eat into the space at all too much. So that's sort of why you'd want to use, say, volumes versus planes. Volumes are generally safer because they've obviously got depth to them, but planes are better when you don't want to eat into the space at all. And of course, fences are good when you have like a defined shape that you want to represent. So let's quickly build a barrier volume here. So the actual barrier itself, by default, is wireframe. And the reason for that is because these are quite important areas when you're working on your game. And I was kind of concerned that if we added opacity to them, they could be kind of annoying, especially if they get in the way of selections. And so by default, the barrier volumes, the barrier planes and barrier fences, they're all sort of wireframe only, which can make them a little difficult to see sometimes because, as you can see here, the wireframe is sort of invisible here. And we can still see this one, but if we'd made this really skinny, like say this, now we literally can't see it anymore. Oh, except here. But it becomes incredibly difficult to actually see the barrier. And so there's a choice that you need to make between, do you want it to be wireframe so that it's not obstructive in any way or irritating, or do you want to have it opacity so that you can see it and select it easier? So I kept that option available to you. It's up to you whether you want it. And that's what this button here is for. This will make all of the barrier actors in the map have opacity or not. So if I enable this now, we can see it really easily. And we can also select it really easily just by clicking. Whereas if I disable barrier opacity, if I click here, it will click the things behind it. But with it on, you can select them really easily. So it's up to you whether or not you want that on. If you do want it on, there is a setting here called barrier opacity on create, which will have them on by default. And so when you build something, it will spawn in with opacity. Otherwise, it will be off. So in the event that you have opacity off, such as like this, it can sometimes make selecting barriers difficult, especially if you can't see them. And so that's why we have the select closest barrier button. So this is kind of, if you have opacity off, but you want to just select the thing and it's difficult to find it or select it, you can just click that and then you can see it selected. So it should aid you in the event that you want to have opacity off. So I already talked about the barrier itself. You can see this red outline. So this is the detected outline of the space. That is, in case you do have opacity off, you can still see sort of what was detected. So it just gives you a little bit of feedback on the space in the event that you can't physically see the barrier. Now, why is the barrier slightly bigger? Now, that's to do with the barrier expand setting, because the purpose of these things is to sort of block detection rays and drones, and they can all be quite fiddly and get right into little gaps and stuff. You want to make sure that your barriers are slightly bigger than the space, and that's why by default I've got a slightly bigger volume. If you wanted to, you could disable this and set it to 0, and now if I build a barrier, you can see that the barrier volume itself comes right to the edge here. But that's probably not the best idea because they're only there just to block detection rays, and you probably want to make sure that they do that well. And on the last visualization point, the little purple dots that you see just represent the detection points that have made it through filtering. Typically, if you're not getting a good barrier, then just move the camera and try again and you'll get a good result. Okay, so settings-wise, the first setting that we have here for barriers you see is the barrier volume class. Now, this only affects barrier volumes. Barrier planes and barrier fences are always use the same Volumator barrier class. There's one per type here. We do have one for barrier volume, but you can change it out. So you could actually use any volume type with the barrier volume. And so then any of those volumes that are placed in the map would then block detection rays and drones. Why would we want to change the barrier volume class? If you're using something like Audio Kinetic Wise, where you're having to put in, say, portal volumes to connect together different rooms, they'll essentially be placed in exactly the same place and shape as a barrier volume. And so you could change over to, say, acoustic portals, and now any acoustic portal that's placed in the map would act as a barrier volume and would block the detection rays. But the other good thing about this is that if we come in and we build a barrier volume with our volume class changed, it will actually build an acoustic portal here because I've changed it over. So now if I select this, you can see that this is an acoustic portal. And so this will work just like any other acoustic portal, but it will also block rays in Volumator. You can see there's no pink dots showing up, whereas if I come over here, you can see there's the pink dots because it's detecting the area behind it. So that can be really handy if you're also having to put volumes in the same places that you want to put barriers, and you can just switch that over. Now, again, this will only affect barrier volumes, but I find typically the barrier volumes is what you're using the most anyway, and that's why that was used for this. It was specifically really for audio connect wires, but there's probably other use cases for it too. So volume depth, this is again just purely for volumes, and it just gives us our starting point for the depth of the volume. So if I build our barrier volume here, you can see it's this length. It doesn't detect this because it's hard for it to know how long you want it to be. So it just sort of puts it in at whatever this value is here. So if I increase this to something really massive, so now you can see it's much longer. It's just a simple setting, just in case you happen to be like, hey, I always want them to be 50 or whatever, then you can do that and you don't have to scale it every time. Now remember that the expand amount takes this into account here too as well. Okay, scanning points, this is simply the number of points that are fired out. It's obviously quite a lot, but the higher the number of points, the more likely it is you're going to get a good reading, but it's going to have a big CPU hit. So you have that control there if you want. Okay, barrier focus is sort of a way to focus the detection points around a sort of central cluster. It's not usually necessary to change, but if you're starting to find the detection system is picking up points that you don't want it to, such as some objects around here like this, you can increase the focus and it will make it more discerning towards the central points that it creates. Let me lower it, and so this will be less focused. I don't know what this is going to do. And you can see it's now starting to detect these points here. It's actually not created a volume because it didn't pick up enough stuff over here, but it gives you an idea of what things it will pass through and what it won't. If we want to be really, really discerning, we can increase the focus and it will start filtering out more stuff away from the central points. So there's two main clusters, obviously left and right. It figures out the average location and then determines how much stuff outside of that central average location it should use. You don't normally need it, but if you start getting weird problems with the context you're using it in, then you can try tweaking that. Min fence height, what that means is when we build our fences, we add points like this, and what it's doing is tracking our height. So if I come up really high here and then finish, the fence is going to match the height that we have here. So the minimum fence height is in the event that we build our fence and we just don't really go up and down much, like this, it's basically going to revert to using the min fence height because we haven't gone up. It's just to ensure that we actually have some height in the event that a user hasn't gone up or down at all, which might happen. So if you want really high fences, you can just set it up like this, and then you can see it's really massive. But you can, of course, always change fence heights. Now, you'll want to scale the individual fence pieces like this, so you could have fences with different heights on them. Let's say I wanted this fence piece here to be much bigger, I could do that. Okay, they're generally pretty easy to use, but if you need any more features or adjustments changed to the way that they work, then please just let me know. Thanks.